Hello everyone, thank you very much for joining me again. Today we continue our JPA and Hibernate with lesson number 8, and we will discuss about inheritance in between entities. If you are watching the event live, remember that you have a live chat there. You can ask me the questions in the live chat. In case you are watching the event recorded, as usual, you can follow me on Twitter, LinkedIn, and of course you can leave also your comments here in the comment section for each video. With that being said, I think it's time to continue. We don't want to lose time. We want to be as efficient as possible, and as I said, we finished about discussing about the relationships, and now it's time to discuss inheritance as well. Inheritance is not one of the concepts that you find very often, but whenever you need it, it might be a very handy thing to use. And of course, it's a skill you need to learn, and that's why we discuss it today. After we manage to discuss this as well, we will be able to get into more details than with a very important subject, which is writing JPQL queries that we will discuss starting with the next lesson probably. So we can say that with inheritance we finished most of the essential things you need to know about entity modeling in general, no? Because we discussed about primary keys, fields, using several annotations such as table and column to alter, to map to a specific structure in the database, to map your objects now to a specific structure in the database. We discussed about all the relationships, and now we discuss inheritance. One of the things that I think I've missed, and I will have to put it somewhere, is using embeddable and embedded. I think I've missed that somewhere, so I will have to put it also in the stream, but it's not such a big topic. So aside for very small things, I think we have covered, together with this lesson we have covered all the essential aspects of modeling the objects for your persistent layers. So then we will be able to step into the next big section of the playlist, which is writing JPQL queries. And there are a lot of things to discuss about JPQL queries, because they basically cover almost completely also what you know from writing SQL queries. So joins, for example, writing inner queries. There are a lot of things that we need to discuss and learn to use with the new syntax. Okay, inheritance. So what is inheritance? You already know from the fundamentals of object-oriented programming that you have objects can inherit one another, no? And in Java you might only have, fortunately, only one parent, so an object cannot inherit multiple classes. It can of course inherit multiple contracts, so interfaces, but that's a different story. That's actually why we call it implementing. I'm not going into more details, that's part of the fundamentals, but we know that we can design an object starting from a prototype already designed by another, no? So we can this way make use of polymorphism as well as reuse the code. There are several benefits why sometimes we use inheritance in part of our object modeling. So let's imagine some entities. Let's say that we have an entity product, and there are several types of products. For our example, and to keep things simple and clear and allow you focus on what's essential, I will only take two, but you could have multiple, no? Let's say you have multiple, but in our case we only have two. It's, say, book and electronic device. Just take two different products, so they are totally apart from one another. So what I've been doing here is I'm gonna take the product, and I would say no, I want to show you something first, so I will not put any attribute. Let's create all the classes. So product followed by book, and book will be extending product, and then electronic device. Hope I wrote it correctly, which also extends product. And what I'm gonna do is I'm gonna make all three being entities. So stay with me. I know it will look maybe strange if it's the first time you see it. Maybe it will look strange that I have to make all three entities, but you will understand everything till the end of this lesson, I promise you. So one of the things I wanna do first, I will try to add the entity annotation on this class, and you will see IntelliJ instantaneously shows me an error which you have probably seen in the previous lessons, which is related to the fact that I haven't defined a primary key. No, so if you go with the mouse over, it should tell you, hey, every entity should have a primary key, whether it's a simple or a composed one. Remember what we've discussed in the primary keys lesson is that even if there are technologies that allow you to skip the existence of the primary key, in JPA you have to define an object related one, which will be if you don't have a single element that we can identify uniquely each record, then you will have to find a composed key, and the worst case scenario, you have a composed key composed of all the possible columns of the table, but that's something more hypothetical, you know. Now the point is that one thing that I want to tell you is to fill in, so what you know, it's not only that an entity has to have defined an ID, this ID might be defined by the entity, as you already know. So I could go here and add the ID at this place, but I can also take the decision to put it in an upper class, and as long as this one is inherited, then there is no problem. So what we can say now is that the ID can be either defined by the class or can be inherited. And that's why, for example, considering that both my book and electronic device will be identified by an ID, I will choose to add the ID here, as you already know how to do. So I'm gonna just put the ID annotation, and I'm gonna define the getters and the setters as well. Okay, fine enough. And then if you go back to the electronic device, we should see that this disappears. I think that the fact that it remains actually is because maybe it really wants to be protected, so it can see that it's inherited and not private. So now going back here, still no, but I don't care. This is an IntelliJ issue, not a JPA issue. I'm just gonna add different now attributes, and to make it simple, I will only add one attribute per each. So let's say voltage was suggested by Copilot. I will not change that because I don't really care what this is. And in the book, let's say we can say private string author, why not? And then getter and setter, and I'm gonna keep it short and simple. I'm gonna add the entity annotation here as well, and I'm gonna add the entity annotation here as well. And what I created here is an inheritance. Okay, okay, probably it wanted me to add the entity, and that's why the error still appeared, because of course you need to have the entity. You will see today it's either entity or mapped superclass, but let's start with the entity. So what I've created here is a very simple hierarchy where I have the product as a parent class. It defines the ID. Of course, it can define any columns that are common to its children, so you can reuse the code this way. And then the children, they of course extend the parent, and then they can add whatever it's different. For example, a book has an author while an electronic device has a voltage. Okay, fine. So now what can we do is define how will this be stored in the database. How is inheritance represented in the real persistent layer behind the scenes, in the in the database, no, in the relationships, or in the tables, and maybe relationships among tables if you have multiple. To do that, you have to know that you have three different possibilities. We name them inheritance strategies. So you have three different inheritance strategies. So now I will start with them one by one and explain how this works behind the scenes, and how what we map and how do we expect them to map, but also which are the advantages and which are the disadvantages. So to choose the inheritance strategy, you have to use the inheritance annotation over the parent class, and then use a strategy attribute, and then the inheritance type enum will define the three possible inheritance strategies, which are joint, table per class, and single table. So let's start with single table. Now I will create the tables so that you can see the result, and I will explain how this works, so you will see which are bad things but also good things of this strategy. And then when we have covered all of them, we can compare them and say, hey, in specific situation I would rather use this than that, for example. That's something that I think a developer or an architect should know how to choose to create their design. Single table, as the name suggests, it will only define one table in the database, and in this table you will have all kinds of products, which means that all the products, and by the way, you can make this class abstract if you want, so that at the code level you will just make sure no one creates instances of products. That's one of the things that maybe will make you wonder, why is this actually called an entity? I will explain when I reach the point where we will have to write a query, and you will see why this has to be marked as an entity. But the idea is that we don't have products, no? We have either electronic devices or books. So these are the things that you should be able to instantiate and persist in the persistent context, so that they are then added in the table. All of this will be in one table. So you will have to have a way. You will need a way to discriminate between the records. You will need to know which is a book and which is an electronic device. And to do that, using this strategy, the JPA implementation, Hibernate in my case, will create a so-called discriminator column. The discriminator column is added to all the attributes, and it's used to specify whether the specific row is, in my case, a book or an electronic device. So let me make sure that Hibernate knows. I have actually, I've copied the previous project and I've cleaned it up because I didn't want to lose time. If you followed my entire playlist, that's the way I'm doing the things. So I have now to update also the managed class names. If I were using Spring or a different framework, I wouldn't need it to do that, because the framework would have taken care of that for me. But since I'm only using Hibernate in a plain Maven project, I need to do that myself. So now if I do anything, nothing will happen because I don't have any operation here. So let's just try to create a book. Okay. Okay, set an ID and an author, and then create an electronic device. An ID and the voltage. And then of course persist them, because you have to do something with this. So I have persisted the book and the device. We expect to have a table with 2 rows with a discriminator column that allows us discriminate between the kinds of products. I will make sure I will leave the DDL on auto this time. In one of the previous lessons I showed you how you have to create, and I always told you, remember that you never have to use this in production, but with examples this saves us a lot of time. And let's see how would the table have to look like behind the scenes if you use this inheritance strategy, the single table. So as I said, you will observe it only creates one table, and in that table there are both our products will be added, and they are discriminated based on a discriminator column. So you see the product table has been created, and inside it you have, well, don't ask me why is the order of the columns scrambled, because I don't know. It's if you have an OCD, please skip over this example because I cannot solve that. So there is no way I know to solve the order of the columns. Anyway, that's not really important since you will never use the automatic creation. No, as I said, you will have to anyway write the script by yourself, and then you will specify your order. But what you can observe here is that we have the discriminator. So the D type is called a discriminator column, and by default it takes the name of the class. You can change that if you want to use some different class. There is an annotation for that. If I correctly remember, it was called like discriminator column or something like that. So you can use this discriminator column if you want to choose a different name than the name of the class. That's your choice, but it's not, I wouldn't say, that relevant. And what is essential to remember is that when you will use it in queries, you will see you don't have to refer. There is no way, you don't even know from the object side, from the app, that this column exists. So you will never have to write something like select products where D type is a book. Automatically, if you select products, then Hibernate will know and will automatically create the right native query using the D type specified. So to demonstrate this, I'm gonna go back here, and let's say I'm gonna comment this out so my tables are not deleted and overwritten. And then what I'm gonna do is I'm gonna write a query, so say var query, and be, first of all, select everything, but not like this, okay? Select everything from products. So I'm using the JPQL syntax. I know I didn't discuss it yet. That's part of the next big section of our playlist, okay? But bear with me. I think you can understand this if you know at least SQL basics. So select all the products. So this will automatically select for me all the products. And I can easily use the entity manager to create. Okay, so be careful here. It's product that you select. So you select the products, and then you get the result list. And if you really want to print them like this, then there is one more thing we need to do to be able to see something readable. Is adding a to string, and this way we will see the result. I'm gonna do that. And now going back, I'm gonna print this out, and what you will see is that behind the scenes the native query has been created without putting any condition on the discriminator, because I selected from products, which means I want all the products regardless of the fact that they are books or electronic devices. So you can see, I know it's that generated native query which is difficult to read, but you can see it's selecting all the values from the table product. Okay, and then you see that I got all, like I got both the book and the electronic device, which are my records. So it doesn't add anywhere condition, it gets me everything. But if I would have said select me only the books, like this, so you see, I just have to refer to the object. There is no discriminator column in the code. I just refer to a type because this is an ORM, that we discussed about. And I always told you, mind to always respect the philosophy of the framework you are using. If you are using an ORM, then do the things in an object-oriented way. So that's why in this case, we refer to objects, and I only have to say, give me all the books. Behind the scenes, it will automatically add me the condition on the D type. So D type is something that Hibernate needs. See, this is the condition. You can see the where clause here, but there is nowhere in the code. So automatically, the JPA implementation, Hibernate in my case, knows that I'm using the single table strategy. It means I have a discriminator column, and it has to add a conditional discriminator column because what I asked for is a specific particular type of children of child that I requested for, which is book in my case. So you can see then the result of executing this query is of course giving me only the record that signifies a book here. So the electronic device is not returned in this case. So this is the single table, the single table inheritance strategy. One of the things that you need to observe here is that whenever you'll use this, aside from the fact that you need one extra column, which is the discriminator, you will always have null values. Null values are really not appreciated in general, having them in persistence. So possibly you should avoid as much as possible using nullable values, but you can't escape them here, because you see, if all of my products are in the same table and you have different products having different values, so you see author exists for the book but it doesn't exist for the electronic device, then you need to have the possibility to store null on all the columns, because at some point there will be products that have the null voltage, like a book doesn't have a voltage, but an electronic device has, while on the other hand a book doesn't have an electronic device that doesn't have an author, but a book has an author. So you need on all these columns, you need them to be nullable, which is not really the best. Okay, so one of the advantages is that having only one table is very simple. You always run the queries on only one table, which means that you avoid necessities for doing joins and unions, but at the same time you have this compromise of needing to be able to store null, which forces you to have certain columns nullable. I'm going back now, so allow me actually to delete this table. And I'm gonna go to the next inheritance strategy, which is the joined table strategy. So let me do that. I'm gonna go to the parent, and here I will say joined. So once I've changed this, I will automatically now have 3 tables. So the joined is called joined because all the values will be segregated in different tables, and then to get all that you need, you will always have to write queries using joins. You have to join the tables when you select, otherwise you can't take the values. You will see it immediately. So that's why it's called joined. And of course, let's see it first. I'm just gonna leave the select the way it is. Okay. And I don't have now, of course, I will not have any. Oh, sorry, it will not work. I had to uncomment this one. Okay, and the big exception. Yeah, I know. Okay, let's do that again now with the property in place. So the tables will be created, and we will see how the query looks like here. And this is the query we are interested in. So you see, yeah, maybe first of all, going back here, let's refresh and observe how the tables look like. So suddenly you don't have one table, but you have 3 of them, and the product will only hold the values that the product class defines, which is only the ID in this case. The electronic device will only have the electronic device. By default, it joins everything on the ID, so the same ID will be in the product as well as here. So that's how it works. And then you'll have the book the same way, but that means that you will always have to join on the IDs to find everything that you need. Okay, so that's pretty nasty. Now the reason it's using the primary key as a foreign key as well here is to avoid to add another column, and it works pretty well, I would say. And normally, of course, you'd have many more columns. The idea is that this strategy allows you to have strongly defined columns for their content. So that means you can have columns that are not nullable, because you will only have to define precisely how a book looks like, and if for you all the books have authors, then you can automatically make this not null, which you weren't able to do in the single table strategy. And in that case, you would have possibly run into inconsistencies. Here you can't run in such inconsistencies anymore, because you will be able to put the constraint at the database level directly. But the disadvantage is, whenever, and now take a look at the query, whenever you want to get something, you will have to join. So you need to use the join, and that way you will get basically all the values, because otherwise you would be possible only to take the specific values, but you always want to get all the values. So to get all the values, meaning to get the values also from the parent, from the class, from the table representing the parent class, you will need to join using the primary keys. As I said, this is the way in which this works. Even if it's requiring more complex queries, and yeah, maybe it's a point to make, hey, I didn't write the join myself, okay? So this is still some trick that Hibernate does behind the scenes, okay? You don't have to write the join yourself. You can write the joins with JPQL. That's something we will learn. But in this specific case where we discuss the inheritance, that's not needed. So you just have to rely, and you can just rely on Hibernate doing all the stuff for you. So that's one thing to one point to make. But the join happens behind the scenes. Okay, you can't escape that. But even if the join happens, and even if this strategy is a little bit less performant in terms of joins, of course, it's more difficult for a database management system to search for your records using multiple tables, using joins and in multiple tables, rather than, of course, querying on only one table. This strategy is very often used because it somehow allows you to keep your database more consistent. And if you don't discuss about a very large amount of data, many records, then joins are not necessarily a problem. Remember that databases today, they are very smart, and if you worked, and I hope you have worked with databases, at least at the fundamentals, the basic level, you know that the database management systems can do miracles in many cases. Like you search through millions of records in milliseconds. You've seen that probably. And if you correctly define your database using proper indexes and having a good normalized model, then it makes the things even easier for the DBMS. So that's why in many cases joint strategy is very appreciated. Usually the choice is between having the single table and the joint strategy. So the two that I have shown you as the first ones, these are the two in between. You will make a choice, so you will usually either choose the single table or the joint. I would select the single table, maybe only in case I know I have like many queries on specific tables. I want to avoid the joins with all my possible ways I can choose. So if I really want to avoid joining, then because maybe that's a lack of performance in joining, then I will choose to use the single table. But as I told you, in most cases, you will choose the join strategy. There is a third one. There is a third one which I don't recommend you. I will show you the third one, but I will tell you, in my opinion, avoid using it. I will explain why. But let me delete these three, and I will allow Hibernate to create other tables for me. And I will change this one in the one named table per class. As the name suggests, in table per class, we'll create a table in which we'll store the books. It will create a table in which you store the products. And this is how it looks like. So let me run it for you. I know at some point it was specified in the specification that the table per class is not mandatory to be supported by the implementations. I honestly don't know if there is any implementation that doesn't support it. Hibernate does support it, but the idea is that having two different tables to keep the books and the electronic devices. Okay, so having two different tables have the following disadvantages. One of them, all the common columns, like in my case it's only the ID. Maybe it's not the best example, but if I would add one more, you will see it. So let me actually do that, because I don't want you to be confused. I will drop them. What I'm gonna do is add in the product one more thing here. So let's see. Let's say that the books and the products have a name, okay? I'm gonna run it again. So what you will see is that this name gets duplicated. So you will have a name in the book, and you will have the name column also in the electronic device, first of all. So you will have this column duplicated, and that's it. Secondly, if you want to select all the products, it will always run into creating an union. And you will probably say, hey, what's wrong with creating an union? I will show you what's wrong with creating an union right after this. So you see the book, and it has the name here, and the device has the name. So it basically, you will end up having duplicated columns. The column will be in the structure, I mean duplicated, because you will have two different tables. So unlike the join strategy where you put all the common columns into one table, so you would join with it, with this you will have to have a structure which duplicates part of the attributes. Fine. Besides that, there is also the problem that if you query for the product, so let me actually query again for the product, meaning query for all the products. I want to have all the books and the electronic devices retrieved. Let's see what happens. Okay, and you will see a query here that creates a union, and it has to basically run a union between the two tables. Now, of course, what's wrong with unions, you will mostly learn in the next lessons, that you cannot use them with JPQL. So the problem is that the union operator it works natively, but it doesn't work with JPQL. It's not supported in JPQL. And again, I know we didn't discuss yet queries because it's part of the next big section of this playlist, but you don't really want to rely on having different tables, because you don't want to rely on if possible, as much as possible. You don't want to rely on having to make unions, because when you will have to write them yourselves in the JPQL, you will not be able to do that. So normally I would say I would choose the joined strategy. And depending on the case, if it's really the case, but I would clearly analyze the situation, maybe the single table. And these are the three big ways in which you can define the inheritance. So you have a situation like this. You can choose to design your objects with inheritance, and the most important thing to know is that you need to map an entity as being the parent entity. And now you will ask, hey, why is this an entity if it's abstract? Isn't this strange? Because entities are those, by definition, those objects that we can use to create instances in the context managed by the entity manager. So isn't this against the definition of an entity? Well, the reason is because you can still make queries on the product, and you saw that the JPQL is polymorphic. So even if you select from product which is defined as abstract, it knows actually that you refer to its children. Okay, so the reason you mark it as an entity is because you want to be able to use the polymorphic approach, in which you create a query and refer to the parent to actually refer to all its possible children. And that's very good. Now, if you don't want that, if you just want to have a superclass that you use to put there the common attributes and that's it, then what you can do is you can mark this instead of an entity as a map superclass. But be careful, because if you mark this as a map superclass and not as an entity, then this query will not be possible anymore. And you can see that I don't even have to run it to show you that IntelliJ already shows me that my query is wrong, because I can't select from something that is not an entity. In this case, what I can do now, if I really want, I can, I'm not sure where that cat came from, somewhere in the deep of my mind. So I can select the book, all the books, I can select all the electronic devices, but I can't use a way in which I can say, hey, select me all of them. So they are no longer defined as an entity hierarchy. They are now two possible different entities. They are seen as, hey, this type is only used to put somewhere in a common place all the common attributes, but not as an entity, so not as a parent entity for the two of them, which doesn't allow you to use the queries anymore. Okay, if we use immutable, inheritance will be applied only on the superclass. Sorry, I have no idea, but I will note down your question and I will research it, because I don't know for sure here which is the correct answer. So let me put it down, and I will research it, and please leave me also a comment so we can discuss it, because I don't know how to answer this one. But yeah, so that's basically with the difference with map superclass versus having an entity. And I know it looks strange to have an abstract entity, but you see now the difference. So that's the difference between being an entity and not being an entity. That's basically the difference. And I think with that being said, I have covered everything I wanted to cover for today. So normally, again, I wouldn't say that we use too often inheritance, but in some cases you may need it. And I've shown you it's quite an elegant tool in some cases to put things. You will see that with queries, which we start learning with the next lesson, you will be even now more and more understanding how the design and the way you design the object helps you write better applications. But we will always take a look on how the query in a native query is created behind the scenes. And you see, it's very important because sometimes what you write in JPQL might be not totally, but might be different in how it looks like in the native, no? Because now you have seen it even today with the inheritance example. We've only written like select all the books, but behind the scenes it was select from, joined on, so or the where condition that was put on the discriminator column. So that are things that behind the scenes happen, and as developer you have to know that they happen, and always when writing a capability you have to be aware of what happens. And one of the things that I'm always teaching my students is always either enable the logging to see the queries and make sure that they are the queries that you want them to be. And secondly, I'm teaching them to use profiling on the queries so that they can see the queries in the profiling tool and then can identify different kinds of errors there as well. And we will again learn that also in the next videos, starting with the next video where we start discussing JPQL. Okay, until then, I hope you found this lesson useful. I hope you will find it useful, and it will help you at some point. And up to next time we meet again, I'm telling you, have an excellent time for learning, and thank you again for being here with me. See you next time. Cheers.